used. By not having that, you don't have valves, you don't have pipelines, you're using a lot of electrical stuff, and you can see as a result of that, you have fuel savings, maintenance cost improvement, but also makes the airplane lighter and it improves the reliability. And what I've shown you here is how we have reduced the profile from pneumatic and moved it more towards electrical. Now, this is crucial, and there's two things here that I want to talk about. One is, as I talked to you already, no engine bleed system architecture, which I already talked about. But other than the laminar flow nacelles and all, the last point, which is interchangeable engine between GE and Rolls, has never done before for any aircraft, commercial transport aircraft till today. What this simply means, and this is really important for leasing companies because they take airplane, give on lease, say to Air India, 7 years later or whatever the lease is up, they take it back, and now they want to give it to somebody else. Today's engines, if you want to change from GE to Rolls, it's going to cost you millions and nobody's ever going to do it, and I don't know of a single instance where it was done. These engines at the wing, you can simply drop the GE engines and attach the Rolls Royce engines and you are back in the business. And what that does is, if a particular airline had a fleet of all Rolls engines, they will simply reject an airplane with G engine because you're not going to have 2 airplanes or 4 airplanes with a different type to maintain all the training and all the spare parts. This is something that is really neat about this airplane, and the leasing companies particularly are very happy. Most airlines really don't worry about it too much because once they buy engine type, they stick with it through the rest of their life cycle. Okay, so next what I want to talk about is the passenger experience, and I really want to emphasize upon you how this airplane is going to change the way you and I fly in the future beginning next year. So some of the key points I have listed here, and we'll go through some of the details on these. It has very welcoming appearance. One of the things we found, we did research with thousands of people around the world, and today everybody knows how tough the security is, particularly in US and anywhere for that matter. And by the time the person goes through removing the jackets and shoes and belts and watches and everything, and you put it all back, you're pretty much not in a very good mood. And so what we wanted to do is change that mindset. You want to have a nice welcoming thing, and we have a mock-up of it in Seattle, and you can see how pleasing that interior is when you just walk into the airplane. Then we did windows that are about 150% larger. Why is that important? We found the reason people in the middle seats don't like to sit, like you have window seats and then you in the middle section in a wider airplane, is when you don't have connection of your mind to what's happening outside, our brain gives us senses that something is wrong. With having these large windows, everybody who's sitting across that entire row can still look outside, see the process of taking off and everything, and we feel people are more connected to what is happening and they'll have a pleasing experience. And by the way, how do I say all this is true? We did a lot of research again, and we had people testing it in different ways, and they have verified that really it makes sense. Then we have more gentle lighting, lots of space for carry-on bags. Of course, that is changing now with the liquids and all those things, but the time we were designing this airplane, the trend was most business people didn't want to check any bags. They went around the world for 1 week and didn't have any other than carry-on bags because they just wanted to get out the plane, do their business and keep going. And I talked about IFE, but I'm going to show you in detail the lower cabin altitude and the cleaner air, because that is also going to make the difference in the feeling we have. So these are some of the pictures of that interior as you come in, the large windows, some of the videos that you can see in the seat back, and it just gives you a pleasing thing that just puts your mind at ease when you are in the airplane. Now, another research we did was we found out what is it that people get bothered with? And all you have on the left side is a whole bunch of stuff like dizziness, dryness, ear pain, fatigue, irritated eyes, headaches, nausea, nosebleeds. These are the kind of things people experience. And what you have in the middle, that if we do a smoother ride, the dots you see with the rest of it, for example, the dizziness will be less if you have a smooth ride, okay? Similarly, if you have a lower cabin altitude, a lot of these problems will simply go away. If you have a quiet cabin, a lot of this ear pain, and fatigue you don't feel. So having studied all that, we try to find out what is it that we can do in terms of technology to alleviate these problems. And one of the things we did to do the smooth ride at the gust elevation. And in this airplane, we can do 8-fold reduction in the people who are feeling the motion sickness on this airplane. You can see instead of feeling the red lines in terms of vibration, you can dampen them and you can see the motion can be significantly smaller. So people who are susceptible to the motion type sickness don't feel bad having this ride. This one I want to spend a couple of minutes on. Most aircraft today that we fly in roughly have a cabin altitude of 8,000 feet. And what that simply means is if you are at an altitude of 8,000 feet on a mountain or something like that, whatever is the feeling at that place in terms of oxygen, airflow, that's what you will feel when you are in this airplane. What we did is we hired a whole bunch of college students and put them in altitude chambers and did it from ground level to 1,000 feet increments as to what they felt. And as you can see in this chart, over 95% people felt better at 6,000 feet altitude. And you can see the benefit of going lower than 6,000 feet was not all that much. Now, why don't you do that today? Very simply, if you want to pressurize the cabin to a lower cabin altitude, today you will need a thicker aluminum, which means you're going to have a heavier weight and you are taking away the payload from cargo and passenger, which makes money. And that is why you can do it. But with the composite material now on the Dreamliner, we could design that element, still keep the weight low, and bring the cabin altitude down. And by the way, the private jets that you see, like the BBJ and all other airplanes around the world that they fly, they exactly fly at about 6,000 to 6,500 cabin altitude, precisely because those guys want to feel comfortable and all. And when you do that, you will find people have less fatigue, less headache. And what that means is if you took a flight on an 87 from Mumbai to London and a 777 coming back, you're going to say after 10 hours, I feel a lot less fatigue when I fly the 87 than I do any other kind of airplane. One of the main reasons, other than air supply and humidity and all those things, is this particular phenomenon that the cabin altitude is 2,000 feet lower, and that makes a whole bunch of difference to our human bodies. And it takes about 8% more oxygen in our blood at 6,000 feet than compared to 8,000 feet. Similarly, in an airplane, when you have 300 people or 250, whatever the number is, there is all kinds of things like odors, irritants, contaminants. And what this does is we have a system in this airplane in 87 for air purification, which will take the ozone, the HEPA filtration, removes bacteria, viruses, and fungus, and also do a gaseous filtration to remove all those odors. And that way, again, you just don't feel as bad sitting in there